This video is on topic 17, which is on the vertex formula and the quadratic formula and goes along with textbook section 410. Now in topic 16, we were estimating the value of key points just by looking at the graph of a quadratic function, or sometimes by being given the values by being given ordered pairs. So for example, I could glance at the graph of a function and recognize that this value right here is the y-intercept, and that it looks like it's at 0, -3, and that these values are the x-intercepts, and it looks like they're happening at 1, 0, and 3, 0, and that this value is the vertex, and it looks like it's happening at about 2, 1. Now, for this graph, that looks pretty accurate, and we're going to go through some problems that involve the equation for this graph and find out that these are exactly correct. But our focus here is on that term exactly. We don't want to look at graphs anymore in ballpark. We want ways of finding the exact solution to each of these questions. So I'm going to walk you through in this lesson, how do we find the y-intercept using the equation? How do we find the x-intercepts using the equation? And how do we find the vertex using the equation? So our first topic is, how do we compute the y-intercept of a quadratic if I have the actual equation? And this is the sort of the friendliest of the three questions that we're going to study. So as we look for y-intercept, x-intercepts, and vertex, the y-intercept is the nicest because we can really use the method that we've been using all along. We're going to find the y-intercept by replacing x with 0 and then finding y. So that means I replace everywhere there is an x with a 0. And that will turn into 0 plus 0 minus 3, which is -3. So therefore my y-intercept is 0, -3. And to generalize it, if I look at the equation and I replace the x's with zeros, I'm always going to get c as my y-intercept. So this is a lot like what we did with slope-intercept form. That last constant is going to be my y-intercept. On the next page, we focus on how to compute the x-intercepts of a quadratic function.